Hi, this is Electronics with Mr. Estabrooks. Today we're going to learn about Kirchhoff's voltage law. Now, Kirchhoff was another historical physicist that contributed a lot to electricity and electronics. And Kirchhoff's voltage law applies to series circuits. So as you'll recall, series circuits are circuits that there's exactly one electrical pathway. So you'll recall from our discussion of how to calculate total resistance that we just take the sum of each resistor, and since they're all equal, that's an easy one. RT equals 3 kiloohms or 3,000 ohms. Now you'll recall from Ohm's law we can calculate I equals V divided by R. And since the total voltage is 12 volts and the total resistance is 3,000 ohms, the total current is simply 12 volts divided by 3,000 ohms. And if you do the math, that should work out to 0.004 amps. And again, rearranging, moving the decimal to put it in proper engineering notation, gives you 4 milliamps. So again, as you know from our study of series circuits, current is the same everywhere, no matter where you check it. We've measured this in the lab, and if you break the circuit here and put in an ammeter, you'll find 4 milliamps flowing. If you break the circuit here, put in an ammeter, 4 milliamps. No matter where you break the circuit and put in an ammeter, the same amount of current is flowing. Therefore, that means the same amount of current is flowing through each one of these resistors. Which means you can calculate the amount of voltage drop across each resistor. And the way we refer to voltage drop across a resistor is VR1. That means the drop in voltage from this point here in the circuit to this point here. So if all the resistors in the series circuit are the same value, the voltage drops, of course, will be the same. That means the voltage will drop 1/3 across this resistor, 1/3 across this resistor, and 1/3 across this resistor. So in that case, we can say VR1 equals VR2 equals VR3. Because the resistance is the same, the voltage drop across each resistor has to be the same. However, when we change the value of the resistors, that equation changes. And you have to use Ohm's law to calculate the voltage drop across each resistor when they're not all the same value. So let's just do that in this circuit. Since we know there are 4 milliamps, right? I equals 4 milliamps flowing through this resistor. We can solve for the voltage across that resistor using Ohm's law. VR1 equals IR1, which equals the current flowing through the resistor, which is the same as the total current, times R1, which equals 0.004 amps times 1,000 ohms. And what do you get? Lo and behold, 4 volts. So the voltage drop, the amount that voltage drops between this point here to this point here, is 4 volts. Which of course, because all 3 resistors are all 1K, it's going to be the same from here to here, from here to here, and from here to here. So you'll notice 4 volts drop here, 4 volts drop here, and 4 volts drop here. If you add that all up, what does it equal? 12 volts. That's what Kirchhoff's voltage law says. Kirchhoff's voltage law, simply stated and mathematically stated, the total voltage is the sum of the voltage drops across all resistors in a series circuit. So VR1 plus VR2 plus VR3 will equal your total supply voltage. And we just saw that that's true in this simple circuit where all three resistors are the same. But if you substitute different values for each of these resistors and you do the Ohm's law calculation for voltage drop across the resistor and then add them all up, they will total up to be the same as the total supply voltage. And that's Kirchhoff's voltage law in a nutshell.